Why do we need first hop redundancy protocols? Well, the picture right here speaks louder than words. What is happening in this environment? Well, our client is configured with a default gateway of 10.1.10.2. Who owns that particular IP address? It's router A. So router A is the default gateway for the 10.1.10.0/24 network. When the client needs to send a packet out of the subnet to reach, for example, this server, it needs to create the frame with the destination MAC address of router A so it can send the frame to the router, and then the router can forward that packet onto the correct destination. So everything is going to work perfectly if there is no failure. But what happens if there is a failure? For example, router A goes away, or the link between the router and the switch fails. What's going to happen to those frames that are addressed to the default gateway? They get dropped. They get dropped. Why? You might be thinking, there's another path, Raymond. Why would they be dropped? Because the client has no idea the other path exists. It doesn't realize there's another router in the environment that could potentially route those packets onto the correct destination. Why? Because the client is specifically pointing to router A as the default gateway, 10.1.10.2. It has no idea that router B exists. It has no idea what router B's MAC address is, so that way there it could create the frames that are sent to router B so the packets could be forwarded on. So in this case, when those links fail, the client can't reach the default gateway. So the idea behind first hop redundancy protocols is to configure the clients with an IP address that could be shared amongst multiple routers that are acting as default gateways. And this IP address that's being shared is called the virtual IP address. And the virtual IP address has a virtual MAC address associated with it as well. And this IP address and MAC address is part of the virtual router. So the virtual router is what the client thinks is the default gateway. And all it is this IP address and MAC address that's being shared by multiple routers that could be the default gateways for that subnet. So the subnet we're working with here is the 10.1.10.0/24 network. And right now we have a router acting as the forwarding router for this particular subnet. So at this moment in time, it's responsible for this. And what is that? It is the virtual IP address of the virtual router. And if you notice, the client is pointing to that address. You see that? So the client is not using the IP address on the physical interface of the router as you see here. No, it's not 10.1.10.2 anymore, and it's definitely not 10.1.10.3. It is the IP address 10.1.10.1, the virtual router. It's the IP address that is now the default gateway IP address. And since there's a MAC address associated with that IP address, we see it right here, 0000C07AC01 in this case, that MAC address is the MAC address that's going to be given to the clients when they perform their ARP request. What's the MAC address for 10.1.10.1? Oh, here it is, right here, boom. And who responds? This forwarding router. Now, what's the other router doing? The other router is acting as a standby router. It's waiting for that forwarding router to fail. Now, how does it know that the forwarding router exists? Because between these two routers, back and forth, they send hello packets. The hello packets, essentially a heartbeat. So that way these two routers know that they exist. And if, for some reason, this router fails now, or this link fails, that heartbeat will stop. It won't exist anymore because one of the routers is not able to transmit it. So that's gone as well. And when that occurs, the other router has the ability to become the forwarding router. And what is it forwarding for? It's forwarding for that exact same IP address, 10.1.10.1, for that exact same MAC address, 0000C07AC01 in this case. Has anything changed on the client? No, it hasn't changed at all. So in this example, the failure occurs, and all of a sudden, instead of the client's traffic going this way, the client's traffic goes this way. So this whole transition over from the primary router that was currently forwarding traffic to the secondary router that's now forwarding traffic is transparent to the end user. So this is why we need first hop redundancy protocols. It ensures that we have high availability and redundancy at our default gateways.